Hi everyone, this is lesson 1-2, analyzing graphs of functions and relations. Our learning target for today will be for you to be able to use graphs of functions to estimate function values and find domains, ranges, y-intercepts, and zeros of functions. This instruction will specifically emphasize estimating function values using graphs of functions to estimate function values. In example 1, we're going to estimate function values. The function f of x is equal to negative 5x squared plus 50x and approximates the profit at a toy company where x represents marketing costs and f of x represents the profit. Both costs and profits are measured in tens of thousands of dollars. Use the graph to estimate the profit when marketing costs are $30,000. Confirm your estimate algebraically. So here's what we're looking at. We have a graph given to us where x represents the marketing in tens of thousands of dollars, and then the y values on the vertical axis represent the profit in tens of thousands of dollars. And what we want to do is use the graph to estimate the profit when marketing costs are $30,000. So since our scale here on the x-axis is in 30,000s or tens of thousands of dollars, 1 represents 10,000, 2 represents 20,000, 3 would represent 30,000, 4 would represent 40,000, and 5 would represent 50,000. So what we're going to do is we're going to go to $30,000 because that's what we're saying our marketing costs are, is $30,000, and we're going to go up to the graph and then estimate what our profit is based on that amount of marketing cost. So if I go over then to the y value from this point on the graph, I would say our profit is approximately $100, right? But remember, the profit's being measured in tens of thousands of dollars, so I have to multiply that number by 10,000. Just like 1 represented $10,000, 2 represented $20,000, we would have multiplied each of these numbers by 10,000. The same thing happens on the profit. If I multiply 100 by 10,000, I get 1 with 6 zeros, which means that the profit is $1 million. Now, we're asked to confirm our estimate algebraically. So what we'll do, this is our estimate right here from the graph. We are going to evaluate the function at 3, because remember the number 3 represented our marketing costs. So we'll plug in 3 for x and see if we get approximately 100 for y. So if I take the function given to me and evaluate it, the x value of 3, I get negative 5 times 9 plus 50 times 3. And if I further evaluate this, I get negative 45 plus 150. So negative 45 plus 150 gives me 105. So my estimate was close. I estimated 1 million. Here, what we actually get is 1,050,000. The number 105 times 10,000 would give me $1,050,000. Now, 1 million was our estimate, just looking at the graph. $1,050,000 is the actual profit when our marketing value is $30,000. Okay, in example 1, we're going to estimate function values using a graph. We're going to use the same example we did in the previous slide, except for this time we're going to use the graph to estimate marketing costs when we are given a profit of $1,250,000. So really what this means is if I want to figure out what $1,250,000 is on our y-axis, I have to divide that by 10,000 because my scale is measured in 10,000s. And if I do that, that gives me 125. So if I go to 125, because our scale here is 25s, and if I go up to 125 here and go over to the graph, this line is going to touch the graph at approximately this point here, and if I go down from there to the horizontal axis or the x-axis, that gives me an x value of 5. Now, if x equals 5, that really means that the marketing cost, since it's measured in tens of thousands of dollars, I would multiply that 5 by 10,000 and get 50,000. So if we spend $50,000 in marketing, we are bound to make a $1.25 million profit. Now, what we need to do is confirm our estimate algebraically. So here's my estimate. My estimate is $50,000. I'm going to confirm that by doing some algebra, and I will do that on the next slide. So we came up with an estimate that our marketing cost would be $50,000 when our profit, or our Y value, is 1.25 or $1,250,000. And what we're going to do is confirm this estimate algebraically, and we're going to take the equation for the function, and I'm going to say that we have 125 for Y, right? 125 for Y was our Y coordinate. Y equals 125 when we have a $1.25 million profit. And that is, again, because we divided 1.25 million by 10,000, because our axis is measured in 10,000s. And I'm going to solve this equation for x to determine, again, x on the x-axis here is our marketing costs. Now, what I can do is I can move this 125 to the other side of the equation and get a 0 here, and I get negative 5 squared plus 50x minus 125. So I moved this 125 to the other side of the equation by subtracting 125 from both sides. And now I see that each of these three terms are all divisible by 5, specifically by negative 5. So I'm going to factor out a negative 5. That leaves me with x squared here, negative 10x here, and positive 25 here. Now, I can set x squared minus 10x plus 25 equal to 0 and solve, but I realize that this is a quadratic trinomial and I can factor it further. So I'm going to factor that quadratic into two sets of parentheses, and this would factor into x minus 5 and x minus 5. And if I'm solving for x here, since the whole equation is equal to 0, I'm looking for what values of x make the equation equal to 0. And if I substituted a positive 5 in for x here and a positive 5 in for x here, that would make our entire equation equal to 0. So I'm going to say x equals 5. So what I've confirmed is that our estimate was exact in that our marketing cost would be $50,000 when our profit is $1.25 million. In example 1, check for understanding, you have Profit A to Z Toy Boat Company, and they found the average price of its boat over a 6-month period. And the average price for each boat can be represented by the polynomial function P of x equals negative 0.325 x cubed plus 1.5 x squared plus 22, where x is the month, and the month is between 0 and 6, not including 0, but including 6. So we started at x equals 0, and then we ended at 6. Okay. Use the graph to estimate the average price of a boat in the 4th month. Confirm your estimate algebraically. You have 4 choices, A, B, C, and D, and hopefully your estimate will match your answer using the equation. One thing I want to mention is that If we're not including 0, then technically right here at x equals 0 should be an open hole at x equals 0. And the reason, again, is because x does not include 0 in our domain. Once you have your answer, press submit, and you are finished.